So today I'm going to take you through our process, how we've been utilizing the Howick machine so far, what our model information output has been thus far, where we started, where we're at now, and then where I believe we're heading with this journey. So quick introductions. I apologize in advance. Ronan Frias, our director of construction design, had appendicitis on Monday, so he had to have it removed. He's doing well, but he didn't want to fly 5 hours, so I'm not sure why. But so a little bit about myself. I'll keep it short. I'm an architect. I have been with KHS&S for 5 years now. I manage the construction design department. I'll get into more of what the construction design department does here in a little bit. But basically, quick about me, grew up around building, been in architecture since 16. I was a draftsman at the small town that I'm from, at the local architect's place. So good experience, went to school for it, enjoyed it, but I've always been interested in construction. So it was a good fit when I met KHS&S. I was doing a hospital, working on a bolt project in Akron, Ohio, and decided to move out to the West Coast. So I'm enjoying the sunshine, and I get to ride my motorcycle every day, so that's good. So basically, quick introduction to KHS&S. You might have heard of us, maybe not. We are a specialty design contracting company. So what that means is we do a lot of specialty designs. We started our West Coast operation 22 years ago. The first project was the Paris Hotel and Casino. So I don't know if you've ever been there, but obviously there's like an Eiffel Tower involved. It's a fake Eiffel Tower, but there was a good intro to the theming world, right? So we've continued that theming work. We do a lot of work for Universal Studios, Disneyland, continue to do hotels, casinos, things of that nature. We also do a lot of standard projects, but large range of capabilities that we do have. So up on the screen, our core purpose is to do everything better. And so, like, what does that mean, right? Like, crazy. No, it's pretty simple. We want to do everything better. So that boils down to every aspect of what we do, but today we're specifically talking about framing. So we look introspectively. We adopted Lean about 7 years ago. It started before I got to the company, but it has evolved. So we're continually looking for ways to improve, become more efficient, frame better, do everything we do better. So prefabrication is obviously a good lead into how we're more efficient, how we're more productive in the field. So nothing new there. We've been prefabbing stuff for a while, well before Howick was involved. The roll formers where we could actually own our own and cut our own studs with an automated process. But so we're learning that process, right? We've had machines for 2 years now. So ultimately, I'm going to go through the services quickly. Like I alluded to, we do themed construction. We also do regular hospitals and things of that nature, university, administration buildings, housing. So you name it, we can do it. But we really pride ourselves on the specialty work. So quick little office locations. We do have our home office for West Coast operations is in Anaheim, and then it's no surprise that the Howick machines live about 20 miles from our office, so close by. It's a good location. We're able to ship parts. We're currently making panels, delivering to a project in Northern California, so we're able to send those out pretty easily. You already know all about the 3200 and the 5600, so Tom did a good job explaining that stuff. Those are the machines that we bought. We're using every day, so they're definitely getting their work out. Told you I'd tell you about construction design. I'm going to tell you about it. So basically what we do, and this is the department that I manage, we use Revit every day. We use MWF, which is a Strucsoft software. It's a plug-in for Revit, and we were kind of integral in helping develop that software to the stage where we use it today. So I wasn't involved in that process, but it is an amazing software. We take the architectural model. We were able to copy out their walls, create our own walls and our own framing model that can be linked back into the Navisworks model and then be clash detected. So again, this is probably not new information. Everybody knows clash detection, BIM, building information modeling. So another step that we do with that process is early on in the construction, like pre-con, we're involved in the pre-con meetings saying, hey, we think it could be framed better, more efficiently here, there. This is a better detail. So we're looking at better ways to frame, perhaps that aren't really kind of captured in the design. We know the architect's concept's there. We try and make that a reality. So all the full process started out, we design it, we model it, and then we clash detect it, then we build it, right? And then we also provide shop drawings, information for the field to be able to build it and build it efficiently. So moving on, I'm going to talk about 3 projects as far as we're going to move from the simple end of things as far as how we output the Howick information to like a medium ground project, and then where we believe we're going with this down the road, and some place that we've actually implemented on a complex project. So the first project I'm going to talk to you about, this is the simple one. It was Westfield Century City. It was a mall renovation. So it was a situation where we had a 16-month contract construction schedule. So it wasn't that aggressive of a schedule, but the stipulation for a mall or even a hospital that's a renovation, it had to maintain, it had to stay open, right? Excuse me, it's a little parched. So ultimately, we were working nights, right? So automatically, a light bulb goes off. How we're going to make it quicker? How we're going to take less tools to the job site? How we're going to be more efficient putting stuff together? Prefab, right? Luckily, we had Howick machines, so it was a perfect opportunity to see what we could do with that. So we did indeed. So this shows you some of the there was a perimeter eyebrow that went around this thing, and I believe we had like 800 lineal feet of it. But ultimately, this is the simplest way we could use it, right? There was no change in what the panels or the design of this thing was. It connected to the structure consistently. They were all the same, right? So there was no MEP running through it, maybe some electrical conduit for lights below, but effectively we were able to put this up very quickly without any kind of changes to it. So I think it says two installers could install 19 pieces of soffit in a 100-foot run in one day. So we had a crew of 6, put it together, effectively do 800 lineal feet in 2.5 days. So just to put that in perspective, if we were going to stick frame it, same crew would have taken a couple weeks at least. So it's crazy how much quicker and efficient this is, right? So that's a simple project. So moving on to where we utilize the Howick more was the California Baptist University. So what I alluded to earlier is when we do the model and the coordination, we're already putting the studs in. We're using MWF, we're placing jam studs, critical studs where they absolutely have to be there for structural purposes. So we're able to run that in the clash detection and say, hey, here's a totally coordinated project, right? It alleviates every issue you'd ever have in construction. Well, that's not true, but it alleviates a lot of them. And so all the clients want that when they're buying a project, right? So we've already done the legwork and put the model information in there. There's a couple extra steps to get that information to be output to Howick for the CSV file, but it's not that many extra steps, and it turns out that it's actually very, very efficient, right? So we've got, we did some first run studies, and we determined that it was 3 times faster for the interior kitting. So what we did for this situation was we developed panels, output CSV files, very precise layout drawing saying this panel goes where, the Howick labels the studs, and we sent this out as a kit of parts. So it wasn't a panelized, we didn't build it in the warehouse, but we did send pallets of these basically kit of parts out to the job site. So here's a little video. It's going to look like these guys are really fast because it's sped up, but it is still very fast. And I'll stop talking, give you guys a break. But I don't know how long it takes. Minimal waste. See, I didn't stop talking for very long, but no extra equipment on job site. There's minimize errors. So it's also very, very consistent and precise, right? We're taking kind of but we have excellent carpenters. There's no slight on them, but it's just more. It's faster, it's cleaner, and there's minimal waste, and it's a very nice. Like, hey, let's see what we can do with this thing. And I like challenges, so I said, okay. So we basically took a scene and developed what we would think, how we would get this into the Howick machine. How would we build it, right? So as you can see, this is all Howick. Now the difference between this and the previous projects that I showed you that were on the more simple side, we actually used model information to output this. Now part of the reason why we didn't have model information for this portion, and I didn't explain that, is For our construction, what we sell our client is basically clash detection for things that we think make sense. It doesn't make sense for us to model every ceiling joist or every stud connection. We find, you know, in history we found that the majority of clashes are with walls. So ductwork, we need, you know, it hasn't been really a value that we can say, hey, we're going to model every single stud in the ceiling. It doesn't make sense. So we do model a plane, like a placeholder essentially for the ceiling that has the thickness. So long story short, we can't output information from the model that we don't have model information for, right? So we wanted to figure out how we're going to use the Howick, so it was all manually input. So I did, you know, I kind of did these shop drawings, this little isometric. But I mean, you can kind of see with this image, a lot of componentry, and there wasn't enough, it wasn't a large enough room to make that worthwhile. So moving on, we said, okay, we know we can do this with the Howick, but we don't know how to output that information automated wise. Anyway, so another scene. This just kind of shows you kind of what the componentry looks like. So we try and make it in manageable sections, 4 or 5 foot sections, and they ultimately kind of go up and the next one slides in. So we design it so it kind of, you know, the next one overlaps, right? And it goes pretty well. Again, more of the same, but custom shapes, right? So it's not just your standard L soffit or a drop, very complex, right? And then this also kind of shows, not part of this presentation, but we also have a panel max machine that has a different way to look at drywall and utilize that. So it basically cuts slices in the back of the board and bends around custom shapes. We can do angles and different things with that. So it's conjunction with a whole prefabricated elements. So again, not smart information, right? But it was successful. We were able to kill production, you know, rates and absolutely get in and out quickly. It was just longer setup time. So ultimately where we want to go with the collaboration with Autodesk BuildSpace and StruxSoft Solutions and Howick is how do we kind of take what we do have modeled, not overproduce, but take that information and turn that into something that we can output without having to go through extra steps, right? So that's kind of the lean thing. So this would have been something that Ronan would have spoke on. This was a kind of a test project for an interview that we were going after. But ultimately, and I know that Nate's going to get into that with his presentation as far as how they're utilizing this certain stuff. So I'm not going to speak too technically on it. But ultimately they use, I mean, there's one surface, or I should say many surfaces that are modeled, but you can see there's no actual framing information. So it's just a surface. So what they do is they utilize a script, a dynamo script, and they cut various sections along this kind of undulating sweep. And then you could build different parameters into it. You can offset from the face of finish, say 6 inches. Let's say this was going to be FRP or some different finish. You know, you figure that into the design. But ultimately you set the structure however far back from surface you want. Then they cut various sections, and this is all through an automated process, right? They run a script and they say, I want a section every 3 feet or every 4 feet, or there's different parameters you plug in. What that section then allows you to do is it creates nodes, and you can place where those nodes go as well, right? And then moving beyond that, you can basically connect structural members from node to node. So you go from this process, writing a script, cutting the sections, placing the nodes, and then ultimately you will output framing information that will be smart, automated, and go to the Howick machine. Cut it out, put it together. It's simple, right? I don't know. That's what we're trying to figure out. So we're in the process now of setting up a residency at BuildSpace, developing further this whole concept of how we're gonna make it a smarter process, because we want to use it for all projects, not just the simple ones. So that is about it. I think I probably rushed through it quicker than I was supposed to, but that's the way it goes. Kaiser, I only thought it was 15 minutes originally, so, and you guys are probably like, I need a break from that guy's voice. So upcoming projects, we're using it on Kaiser Baldwin Park. University UCSD is currently going, and Lawrence Berkeley National Lab, so that's up in Northern California. We're actually sending panels up for that now. Universal Studios, I'd love to tell you what the projects are, but I can't. Again, it's all confidential. That is it. We're not going to talk about questions because we're going to bring them in later, but hopefully write them down, or if you had any, we'll talk about them at the end.